Hi, it's Jerry Dennery of the MathWorks. So in this last video of this problem, we're going to just kind of wrap it up and we'll answer this last question, which is how long will it take for the block to travel 2 meters down the ramp? All right, so I kind of did this at the end of the last video. I'm going to correct that, but I'm going to kind of, which means I'm going to put it back to what I had before, which is, and that's our equation for x. So I was merely kind of showing how we're going to do this one. And so paste it in right there. All right. And basically, we're going to get to the answer, or we're going to get to the position of minus 2 meters down the ramp. And we're going to solve for the t that's required to do that. And it might be pretty clear to everybody right off the bat, oh, we got t squared, and ultimately we're solving a quadratic, and we're going to use the quadratic equation. All right. And so I'm going to rewrite this a little bit. All right, and so I'm going to begin with, I'm going to even call it I'm going to call it ACC for right now, right, times t squared. Because as we get into quadratics, of course, we like to use a, b, and c as the coefficients in the terms, and we know essentially minus b plus or minus square root of b squared minus 4ac and all that kind of stuff. All right, so ACC times t squared divided by 2 plus v0 times t plus x0, and then we'll add 2 to both sides, so we'll get plus 2, and everything is equal to 0. So we got that format, and it's getting pretty close, right? And so now let's get into our coding for this, and hopefully this will be okay. And I'm going to essentially introduce, the a, the b, and the c. All right, and so a will be equal to, in our case, it's acceleration x, Control C, and we'll divide that by 2. Actually, I'm not going to suppress it. It's good to, get what those numbers will be. All right, so let's see, b will be pretty simple. It's equal to v0. And then c is pretty easy too, and that's x0 plus 2. All right, and so we're going to be solving for these t's that will do this, and since there are going to be two terms, it's the answer is minus b plus or minus square root of b squared minus 4ac, all divided by 2 divided by a. All right, and so I'm going to call my two roots. Call one is going to be tp, and that's where we add the radical. Right, and so let's put all this in the b. Right, so we're going to add it. So minus b plus square root of b squared minus 4 times a times c. That looks pretty good. And so then we divide by, again, the whole quantity by 2 divided by a. Now let's put our equal sign in there. And I think it's a good idea. Let's hit run. All right, and so we got a negative number. And haven't exactly worked through what does that really mean, but I think it means that I think it means something like if we went up the slope and back in time. Again, too much philosophical implications on that one. So I'm going to merely disregard the root because I'm looking for something positive. Right. So let's do the negative term for this. Control C. And I'll paste that in. And this time I will call it Tn, T sub n, and that we'll use the minus sign from the quadratic equation here. Right. And I'll hit run. And it's kind of funny how the negative one actually gives you the positive root. All right, and so the basic answer is 1.1, about 1.12 seconds, which is a little bit bigger. We went 2, down the hill 2 times, and therefore it's a little bit bigger than 1. And I'm tending to believe it, but I think I will do this, which is, well, let's solve for x. I'll just call it 2, because that's what we're supposed to be getting, and we'll use the same basic equation we had here. Control C, Control V, and T1 will be replaced with Tn. Do that right here too. Right. So my basic validation here is to prove that that solved for time value will produce a value of 2. So let's go ahead and hit run. And perfect. And now I'm pretty happy with all this. And so just to kind of wrap up, these 3 videos, we're doing, because we're doing this with a live script, we're doing a little bit more than just kind of solving a problem as asked. What we ultimately did was we kind of created a template. And we included things like, well, from rest. Well, what if it really was, going up the plane a little bit? I think we got the answer here. Let's go ahead and hit live editor, hit run, and of course it would take a little bit longer for it to kind of stop itself and then make its way down the plane. And so that'd be about 1.5 seconds. And what the plane wasn't 30, let's say it was 10 degrees. Right? And all that calculation still there. That's going to convert it into radians, and we'll do those sines and cosines over and all that kind of stuff. And let's see how we did. Right. And I'll just say I'm a little bit troubled. I'm seeing negative numbers here. And I think what I'll kind of take a look at, actually my V0, that I just kind of threw in that idea on this one. Let's make it 0. But in both cases, there's going to be an interpretation required. And if V0 is actually 0, and I reduce the plane to 10 degrees, I'm getting complex numbers. So all that seems kind of wrong. But let's kind of go back up to one of our initial questions, which is, was the static friction force on the block? And we essentially compared the driving force with the limit. And we're going to see that, well, the driving force is now amplitude of 17.01 or 02. And that's actually less than the static friction limit, and hence the block never would have even moved. All right. And so, so anyways, I think this is the point of coding, which is that you're kind of capturing a structural, kind of solution that will continue to work as you really do kind of, I'll say change up the data, which really means change up kind of the change up the description of the problem, which is really provided by these parameters. So anyways, as I said in one of the I think the first or the second video, if I was going back to college and taking all these like math and science and engineering classes now, I'd probably use MATLAB and live scripts for almost every bit of it. So anyways, I hope you like these, and love to hear what you think. So if you have the opportunity to provide comments, I'd really like to hear what you think. So anyways, thank you. I'll be producing some more. Thank you.